Thank you, Sini. And moi to all of you. Like Sini was saying, my name is Jaska Rantanen, and I work as a senior specialist mechanics at TactoTek. I've been doing mechanics design for about 20 years now, and from which last 2 at TactoTek. And although I have a lot of experience about a lot of different industries, I still feel that the task I was giving today to come here to speak about IMSE Mechanics is one of the most challenging that I've ever had. So there has been a lot of comparisons today, so let's start with one. You've seen this picture already. So there's the traditional way of doing overhead control panel. The black flat part on the top left corner is the front panel that you can see in the final product. It's been most likely designed by industrial design together with other functions, so there has been a lot of like lights, buttons, switches, and stuff like that integrated into it. Most likely, this is imaginary. I haven't done this, so I really don't know, but I would imagine that, for example, lights. There is some illumination people. They are doing their illumination design. They design the lenses, light guides, light blocking, like gaskets and stuff. And then they bring it back to here. And they do it in several times. And the same is done on the buttons. There is some mechanics, some electromechanics, and so on. And it all been bring back to here and put together. And then there has been some mechanics design done to make all those functions to come through. And then most likely there has been some assembly and assembly testing and testing itself and so on. So there has been a lot of people involved in this process. And the end result is that we have an assembly that has more than 60 parts. So how does this differ from IMSE Mechanics? The big thing is that it actually doesn't. We have all the same elements there. We have the industrial design, we have the hardware design, meaning printing, illumination, antennas, IML films, injection molding, tooling, testing, manufacturing, materials. It's the same elements are there. So there's a big difference there. And if you have paid any attention to the Paavo's presentation, Anne, Tuomas, Opasi, you have actually seen the IMSE Mechanics design already. Let's take a deeper look at the industrial design, for example. It's actually amazing that if you give these people a little bit of freedom, you can describe your problem, and some time, of course, they need. They will end up into the most beautiful things that you can imagine. What it means for us, the mechanics design, it means that we just need to check out that this thing can be done. Meaning like the IML film on top of the product, it just needs to be checked that there is enough radiuses, drafts, and stuff like that. And of course, at the same time, like in the previous example, all the functions need to be defined. The location for the functions, what they are, how those are illuminated, if there is any like sliders or whatever there's needed. But it's been done together in this process phase. This also could be done by mechanics design. But you wouldn't see beautiful surfaces. You would see just only squares and rectangulars, and perhaps some Minecraft world. So from there, we go to the illumination design. Once we have the beautiful outer surface done, what mechanics do, the first thing is to create the functional backside. It also means that the part will have its thickness, and that leads us into the material selections, which is then done together with the illumination guy and the material specialist, and of course the application where the manual is going to. And once we have, for example, the on-off icon defined, we can then start to check out how it can be done. If we are lucky, we can find a reference design that has been done by Paavo's team, and it's been certified. It has the icon size, it has the luminance value, uniformity value, and the components defined already. And we can place that on the 3D surface, the functional back surface, and start thinking about how the components could be located. And like I said, if we are very lucky and we get the reference design like this, we have already rough positioning of the LEDs, what we can play with, the distance from the icon, and so on defined. All we need to do is to check that there is no like screw towers or anything beneath those LEDs. From there, we actually jump into hardware design. And now we have the 3D back surface and the component on the surface. The first thing to do is to make that beautiful 3D shape back to 2D shape for the hardware design. Because the hardware design is done in 2D world, mainly today. Okay, there is some news coming, and hopefully even more in the future. At the moment, we are using tools like sheet metal to do this. But as its name states, metal, it's really designed for the metal, not for the thermoforming plastics. And it doesn't work as such on our cases. With some lessons learned and tricks, we have been able to do this, and then the hardware design can do their magic and put the wires and rest of the components on top. From there, we need to go back to the 3D shape and check out once again that if any of the wires that have been placed or other functions there are in a place where they cannot be, like on top of a screw tower, on a rib, or something other demanding, for example, geometrical shape. And all these things are done together and in constant communication between other departments. Oh, have I missed anything? Antenna. Okay, you all can see that there's the Bluetooth antenna. Well, I used to work in the mobile phone industry for more than 10 years, and still I can say that I don't figure out these things. Sometimes they need some space around them, and sometimes they don't. When you give them ground clearance, they ask, no, don't go that far, come closer. So I have gave up. And all I do, I give the space, the real estate, and the form for the antenna designers that they can do their magic. And if I ask nicely, in our case, Anni will give me the design that how it should be. And I'm happy if Anni is happy. So no more details about this. So this is pretty much all that I can say about IMSE Mechanics. That it's just, there's all the same elements as in the traditional design. Only thing is that you really need to work together in close operation with all these departments. It's like a friendly ping pong game, that you just try to continue the ping pong as long as you can, so that you can find the best possible outcome out of the design. A few words about the tools that we are using. Actually, we have been lucky to use very good tools that has been provided by Dassault Systems. These tools are not mandatory tools, so that you can use any tools that you have, as long those tools work together. Just like the IMSE design. And that's pretty much all that I have to say.